go ahead and look at this worksheet. This is the worksheet that we're going to be doing preparing for the test that's on Friday. The test will be on ratios, rates, percents, and unit rate. And there will be a few questions on each. You'll need to work on this to be able to study for the test. Before we start, the best way to study for a test is to look at a problem, try to do it by yourself. If you don't know what you're doing, then go ahead and watch the video. If you think you might know, do the problem, try it, and then check your work. If you got it right, awesome. Move on to the next problem. If you got it wrong, then watch the video and try and figure out what you did wrong and how to do it the right way. Let's go ahead and get started with question number one. Question number one says, what is the ratio of small shirts ordered to the total number of shirts ordered? So some key words here that I want to point out. We've got, it's a ratio, so we're going to have a colon, something with a colon. And we've got small shirts to total number of shirts. So in looking at my small shirts, I'm trying to figure out, okay, I've got my small shirts, and it's going to be comparing the small shirts, which is here, the small shirts, to the total number of shirts, which is going to be total number of shirts, total shirts here. And so what I want to do is I want to go ahead and figure out, okay, how many small shirts are there? But before we do that, let's go ahead. Small to total. And I just like to set up this T-chart. So my small shirts, here are my small shirts. And I can go ahead and highlight those in blue. Small shirts, right there. They're in green. My bad. And so my total shirts actually is going to be everything. So we'll do that here. This is here, and then here, and then here. So it's everything added all together. So let's first add up the total shirts. 6 and 14 is 20. 5 and 5 is 10. 4 and 6 is 10. So we'll add them. 20, 10, 10, that's going to be 40. So my total shirts is 40. Then my small shirts, 6 and 14 is 20. That's going to be 20. So clearly 20 to 40 is not an answer, so we need to simplify. I know off the bat, since I have zeros, I can divide by 10. Here I can divide by 10. And so that's going to be 2 to 4. And then I can continue. Okay, we've got the small to the total. And so here I can divide by 2. Here I can divide by 2. And so I have 2 divided by 2. And 4 divided by 2 gives me 1 to 2. So my ratio is 1 small shirt to every 2 total. So that's going to be 1 to 2, B as my solution. Let's go ahead and look at question number 2. It says, in a class of 24 students, 16 are girls and 8 are boys. And then it says, what is the ratio of boys to girls? So this is going to be a little bit of a tricky question because it's asking for the ratio of boys. So I've got boys to the ratio of girls. And so I'm going to have girls. And so as I'm looking at this, it tells me in a class of 24 total, this is my total, 16 are girls. So I can already put 16 over here. But it says that it's 24 total. Well, how many left are there to be boys? Well, 24 minus 16 is equal to 8. So 8 plus 16 is 24. So that tells me there's 8 boys. And so in this case, we're going to go ahead and go down, simplify. 8 goes into 16 2 times, so I'm just going to divide by 8. 16 divided by 8 is 2. 8 divided by 8 is going to be 1. My ratio is 1 to 2, which you'll notice the answer is not over here. So that tells me, okay, the answer is actually correct if you've got 1 to 2, and the answer choices here are all wrong. Let's go ahead and go on to the next problem. Question number 3. It says, what family has the best babysitting price? The Smiths, the Halls, or the Johnsons? So as we're looking at this, I'm going to suspect that the Halls probably have the best because Mr. Hall made this worksheet, wants to make himself look good. So we have, again, we're trying to find the rate. And so we're looking for, this is my pay. This would be dollars. And so usually we would do dollars per hour when we're setting this up. So, and we're trying to find how much for 1 hour. So let's go ahead and set it up. All right, I got 240 over 20. And so I can use my calculator. 240. And remember, when we do this, we're dividing down and then multiplying up. Because our arrows are going in opposite directions, and so we're going to use opposite operations. 240 divided by 20 is equal to 12. So this is dividing by 12. And so then here, if I have 1 times 12, I get 12 because it's 1. So really, I don't even have to multiply because I know already it's going to be 1 times the number. So this is $12 per hour, and that's $12 per hour for the hauls. Then let's go ahead and do the next one. So I'm going to draw a line here. I've got 160 over 15 hours. Dollars is equal to how many per 1 hour? And so again, I'm going to divide down and then multiply up. So I've got 160 divided by 15. That's equal to 32. That's a pretty nice deal for babysitting. $32 because when I multiply by 1, I get the same team. So that's 32. And then finally, I have $250 per 22 hours. And I want 1 hour. So again, I'm going to divide down. And then whatever I do that side, I'm going to do the opposite, multiply. So 250 divided by 22, and I get 11.36. So clearly, 160 divided by 15. I divided this wrong over here. This should not have been 32. That should have been 10.66. So this is actually 10.6. And so our answer is going to be the Smiths. And notice that when I saw that 32, it just seemed odd to me. And I was like, okay, if I divided by 10, it should have been 16. So that just seemed like a bigger number than what I needed to have. And so it's actually the Smith, and Mr. Hall's the stingy one. So the Smiths. Hey. Let's go ahead and take the next question. John traveled 360 miles each day for 10 days. If he traveled 12 hours each day, what was the unit ratio of miles per hour? And then it has, okay, it's miles. We're looking for miles per hour. And it tells us that here. What was the unit ratio of miles per hour? That's a key. So we're going to set it up. Miles per hour. So it tells us John traveled 360 miles, 360, each day for 10 days. So if he traveled 12 hours each day, what was the unit rate of miles per hour? So we've got 360 miles and 12 hours. This 10 days doesn't even really matter because each day, and that was 12 hours each day. So this is per 12 hours, and it's asking me per 1 hour. So let's divide down. You got to not get tricked here because this does not matter. 360 divided by 12. Well, I know that 12 goes into 36 3 times. So I'm dividing by 3, and then there's a 0, so that's divided by 30. So up here, since our arrows are going opposite directions, we use opposite operations. This is going to be times 30, and I just get 30. So 30 miles in 1 hour. Go ahead and go to the next question. Next question, candy bars are sold at 8 packs for $32. Each pack has 4 bars. And ask, what is the cost of 1 bar? So again, this is a unit rate problem. It's asking us for 1 bar. So let's set up our ratio. Something equals something. It says that candy bars are sold at 8 packs for $32. And each pack has 4 bars. It says, what is the cost for a bar? And here I have cost for a bar. Now here's the problem. It gives us packs. That's an issue. But what we do know is that this is $32. but we don't know how many bars this is. But there's 4 bars in a pack. So if I were to take 4 times 8, that gives me 32 bars in one pack. Bars. And you could draw a picture of this. I could have, that's a pack, this is a pack, and there's 4 bars. 4 bars. 4 bars. 4 bars. So that'd be 4, 8, 12, 16. And we could keep going, but I don't think I need to. You get the idea. But there's 32. So that's $32 and 32 bars. So that makes it actually pretty easy. So the cost of 1 bar, since they're the same price here, this would just be dividing by 1. So then I do times 1. 1 times 1 is $1. Let's look at question number 7. How much money would you earn if you worked 40 hours? So let's find the relationship. Again, we have 20 times 5. And we know, not times 5, 20 times 10. Let's erase that. So it's 20 times 10. We know that because we just added a 0, but you could also have done 200 divided by 20. And that gives you 10. And so then this would be times 10. And then this would be times 10. And so we know 40 times 10 is 400. And that would be 400. The other way you could have done it is you could have set it up. So I've got hours, and then I have dollars. And so we could have had 20 hours, $200, and then we could have had 40 hours, and we got to figure out how many dollars. So we find our relationship. Again, if we're going down, we divide it, or you can multiply. This would be 200 divided by 20. And so I use my calculator. This would be times 10. And so that's going the opposite direction. Yeah, and this is right, times 10. And so my arrows need to go in the same direction. So I do times 10. 40 times 10 is equal to 400. Let's go ahead and look at the next question. Number 8, find the missing value. So these are pretty easy. This is times 5 is 25. 7 times 5 is 35. 8 times 5 is 40. So 11 times 5 is 55. Next one. 12 times 2 is 24. And 4 times 2 is 8. So times 2. So if I'm going across this direction, and I'm going across this direction, if I'm going the opposite direction, I'm going to do not times 2, but divide by 2. So 16 divided by 2 is 8. So that gives me my solution. Here, 12 times 10, because I just added a 0. This is times 10, so this would be 160 times 10. Here I have 2 times 8 is 16. 5 times 8 is 40. 8 times 8 is 64. And 10 times 8 is 80. Let's look at the next problem. Chris can run 6 laps in 18 miles. How many minutes will it, 18 minutes. How many minutes will it take him to run 8 laps? So we're looking at minutes and laps. So I've got minutes and I've got laps. And I got to set it up. I've got minutes and I've got laps. Okay, so it says he can run 6 laps in 18 minutes. So that's 6 laps, that's 18 minutes. And then it says, how many minutes will it take him to run 8 laps? So I'm going to put 8 down here. Notice my units are super important because it tells me where to put my numbers. Laps on the bottom, laps on the bottom. 18, if I take this, I can divide. 18 divided by 6, if you know your multiplication tables, you know it's 3. So that's going to be divided by 3. And then since that's going down, my arrow over here is going to go up. So this is going to be times 3. Because the opposite directions, we use opposite operations. So this is going to be 8 times 3. 8 times 3 is 24 minutes. So my answer here is 24. Next question. Jill is making cookies that call for 24 ounces of sugar. About how many grams of sugar does Jill need? Okay, this is interesting because we've got ounces here and we've got grams. And it says 1 gram is about 2.5 ounces. So let's set up our ratio. I've got ounces, which is OZ, and I have grams, I have ounces, and I have grams. Now it tells me 1 gram is 2.5 ounces. So that's 2.5. So then it says we calls for 24 ounces. So let's put 24 over here. And so now we just do our operation. So again, same deal. Draw our arrow, divide, 2.5 divided by 1. You should know if we divide by 1, we're going to get the same number, 2.5 divided by 1. I end up with 2.5. So this is 2.5. Now I draw my arrow. On the other side, since my arrows are going the same direction, I use the same operation. So this is 2.4 divided by 2.5. 24 divided by 2.5. And I get 9.6. So 9.6 grams is my solution. Next problem, number 11. Shaq is 7 foot 2 inches tall. How tall is he in inches? And it says that 1 foot is equal to 12 inches. Well, this is pretty easy. We just need to figure out how many feet is in inches, and then we have 2 extra inches. So that's going to be 7 times 12 is equal to 5 times 12 is 60. 6 times 12 is 72. 7 times 12 is 84. Plus 2 extra inches, because it has these 2 extra inches, and so that's going to be 86 inches tall. Question 12. A tree is 220 centimeters tall. How tall is the tree in feet? So it says 1 foot is equal to 30. That should be 30 centimeters. So we have feet, and we have centimeters, and then we have feet, and then we have centimeters. So let's look at it. A tree is 220 centimeters tall. It's going to be 220. And it says 1 foot equals 30 centimeters. So I'm going to put 1 foot, 1 foot, 30 centimeters. So let's find my relationship. Here, to go down, sorry, we're going up to 30. So 1 times what is 30? Well, that's times 30. And so if my arrow is going down here, my arrow has to go up here. So that's pretty easy, because here we did times 30, opposite direction. So we do opposite operations. So this is divided by 30. And then I can do 220 divided by 30. And we get 7.3. And so that should be around, you could round that to about 8. But that's not an exact solution. Better solution would have been around 7, would have been to round that. Next problem. 40% of people at the football game were kids. There were 240 people at the game. How many kids were at the game? So first off, it tells me percent. So I know directly, I'll set up my ratio as a percent problem. That means I have 100%. And remember, I don't have to put the percent sign. It just helps me to remember those percent. It says 40% of the people at the football game were kids. 240 people total at the game. How many kids were at the game? So we've got kids and we've got kids. So we don't have to do any fancy math and subtracting. So we have 40%. Again, I don't need that percent sign, but it just helps me to remember. And then 240 total. So my total goes down here because I have the part and then I have the whole. And the whole is 240. So let's look. Here, we can divide down. 40 divided by 100. And if you know how to do this, you should end up with 0.4. 40 divided by 100, because we just move our decimal, 0.4. So I divided by 0.4. So then what I'm going to do, I got to draw my arrow up into the unknown space. And so that's 240. Since our opposite directions, we do opposite operations. So this is times 0.4. So I have 240 times 0.4, and that's equal to 96. And so that's going to be 96 kids out of 240 total people. Question 14. In Mr. Hall's class, 20% of the students are going on a class trip. If 12 of his students are going, how many students are in Mr. Hall's class? So already we have a percent problem, so let's set it up. I have percent, that's 100%. I don't need this percent sign, but it helps me to remember. Mr. Hall's class, 20% of the students are going on a class trip. If 12 of his students are going, how many students are in the whole class? So this helps me. They're both going. So that tells me they're the same. 20% connects with my part, which is how many students are going? 12. Is the whole class going? No, just part of the class, and that's my part. This is my whole. And it asks how many students are in Mr. Hall's class total. So that's where my box goes. Okay, let's find our relationship. 20, I can divide down. 20 divided by 100 is 0.2. And so I have to draw my arrow down into the box. And so my arrows are going the same direction. So I'm going to use the same operation. So this is divide by 0.2. So 12 divided by 0.2. I get 60. The other thing you could have done is you could have done, well, 20 times 5 is 100. You could have done 12 times 5 is 60. And same thing, dividing by 0.2 is the same as times 5. So I end up with C, 60. Next problem, number 15. What percent of students chose soccer as their favorite sport? So it's a percent problem, so already I'm going to set up my percent problem. This is 100%, and I don't need this percent because I'm just putting it there to remember. What percent of students chose soccer? And percent is here, because I don't need it, but I'm putting that to remember. So I'm looking for soccer, and I have my part and my whole. Well, my part's obviously going to be soccer, and my whole is going to be the total. So I've got soccer here, that's 10. 10 soccer. Out of how many total? Well, this is 10 plus 8, that's 18. These two, 5 and 7, is going to be 12. And these two, when I add them, is going to be 30. So it's going to be 30 total. And so what percent is it going to be? Well, let's divide down. 10 divided by 30. I should end up with 0.33. 10 divided by 30 is 0.33. So this was dividing 0.33. And then since my arrow is going the opposite direction, we're going to use an opposite operation. So I divided by 0.3, so I'm going to do 100 times. So it's times 100. And that's 33.666. So that's going to be 33. 33%. Again, opposite directions is opposite operations. Last one. LeBron James shot 80% from the foul line. He made 16 shots. How many shots did he take? So it's asking me how many total shots did he take. So I already know that's my total that I'm looking for. Let's set up our problem. It says percent. So already I'm going to put 100, a little percent. I don't need this percent. I'm just putting it there to remember. I don't need this percent. I'm just putting it there to remember. So this is going to be, he shot 80% from the foul line. So that means he's making 80%. He made 16 shots. So these correspond. So that's going to be my part. It's not everything he did, just the ones he made. So that's 16, that's my part, and that's 80%. Then we're going to go and it says how many shots did he make total. So we don't know the total. So let's find our relationship. Here I can divide down. 80 divided by 100. 0.8. And so then if I'm doing the same thing, so my arrows are going in the same direction, so I'm going to use the same operation. So I'm going to divide by 0.8. So that's 16 divided by 0.8. And we get 20. So that's 20 here. And that should be it. If you have any questions, go ahead and go back through, and then you can ask on Monday mornings, on Friday morning, whenever we come in and we're working together.